Now this guy has a lot of transforming going on. We've got, let's see, well, the function is the cotangent of x after a horizontal stretch by 2, that's the x over 2, which is really instead of dividing or shrinking by 2, you're actually stretching it by 2. A vertical stretch by 3, and a vertical shift up 1. So that's what my description is here. So I use the basic cotangent values of x equals 0 for the asymptote, because when you plug in 0, the cotangent value is undefined. Pi over 4 comma 1, pi over 2, 0, etc. And I horizontally stretched each by 2 by multiplying the x coordinate by 2. Vertically stretched by 3 by multiplying the y coordinate by 3, and then vertically shifting up 1 by adding 1 to each of the y coordinates. So I get the values, the final values here. I have plotted those, I have labeled them, I have drawn my really stretched out cotangent curve, and now it's pretty easy for me to identify the domain. It's all real numbers except negative 2 pi, 0, 2 pi, dot dot dot. The range is all real numbers. The period of a basic cotangent curve, like tangent, is pi, but this has been horizontally stretched out to be twice as big, so now it's 2 pi. Which means the frequency is 1 2-pith. The asymptotes are going to be, again, you can pick the same values that you left out of the domain or just something within that pattern. So I could have put dot 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 0, 2 pi, 4 pi, dot dot dot. And then again, some example end behaviors left for your review. Here's an example very similar to what you'll see in your homework. For cotangent, again, I've done just the basics of what you would be required to do by following the directions in your homework. I've described how the cotangent function is related to number 9. I have described where the vertical asymptotes are. I have then graphed exactly 2 periods of the function, making sure to label a period's worth of asymptotes, center points, and corners.